So today we will see few of the modes and how to measure the phase and frequency. Okay, phase and frequency in your CRO. Those things we are going to see. So in today's session, we are going to cover the theory part. In the next session, we are going to see your questions of CRO. Okay, questions of CRO, and we will start our next topic also. So you can see basically already I have explained to you the YT mode of CRO. Okay, YT mode in your CRO. So in YT mode, basically what we do, in YT mode, we can measure your average value, RMS value, your time period of the signal, frequency of the signals, all those things we can measure in your YT mode of CRO. Now, how do we basically sketch a signal using YT mode? So you know what, basically this VY, this is what? This is your unknown signal. Okay. And this is what? What is this signal known as? This is your time base, basically a ramp signal. So time base, it is given to your vertical plate. Okay. Vertical plate, or basically it is your horizontal deflecting plate, and Vy is basically your unknown signal. So this is what? This is your horizontal deflecting plate. Okay. We all know these things. So this is your horizontal plate. This is what? Sorry, this is your vertical plate. I have written horizontal plate. So this is your vertical plate, or what? Horizontal deflecting plate, or this is your horizontal plate. Okay. So now you can see I want to do what? I want to plot this unknown signal on the screen of CRO. So it's very simple. What you can do, you can take different time instants over here. And the corresponding signals, corresponding time periods you can take over here also. So we know what? We know what basically we know what? That basically we are vertical deflecting plate, and this is horizontal deflecting plate. Okay. So if this Vx was not present, simply if I wanted to curve this sinusoidal, so you know what? It will look like this. First, this curve will be traced. Then once again, this will come down, and continuously this curve will be traced like this. Once it will go up, then again down, up and down. Okay. So continuously this will go down. But the moment I have this time base, so this point, okay, let this be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 points I have taken. So the first point, you can see both of the signal have 0 0 voltage, so it will be plotted over here. In the next case, you can see this 2 and 2. So only if this 2 point Vy was present, if this was not present, then the signal would have come over here. But as there is also voltage applied in your what? In your horizontal deflecting plate, this point, it will shift over here. Okay. Similarly, the third point, it will come over here. Fourth point will come over here. Fifth point will come over here. Sixth, seventh, eighth, ninth, 10th, 11th, 12th. So like this, you will have what? You will have your sinusoidal. Either it might look like this, or you can even set the signal to look like this. It's up to you. Okay, it is up to you. We don't know, basically at the moment, we don't know how this signal will look on the screen. Okay, we know that exactly this much part will be replicated on the screen. Tell me, up to this point, is there any doubt? So we have already seen this thing. Any doubt in this? Shishir, any doubt up to this point? Whatever we have seen. So now today we are going to see something new. Okay, something new. See, if this is the voltage applied on what? Applied on your vertical plate, and this is your time base applied on your horizontal plate. Okay, so you can see this is what? This is your sweep signal. There is no retrace time. I have assumed that the signal, in the signal, there is no retrace time. So this is the time period of the sweep. Okay, time period of the sweep, and this is the time period of the signal. And from the diagram, you can see basically that the time period of sweep is exactly equal to the time period of the signal. Okay, time period of the sweep is equal to time period of the signal. Now, how many cycles are going to be displayed on the screen? How many cycles of this signal is going to be displayed on the screen? See, basically, time period of sweep means what? Time period means that this much time is basically overlaid with one end to another end of the screen. That means you can map this much time on the screen from this point to this point. So obviously, when you have this much and time period of signal is exactly equal to the time period of the sweep, that means exactly in this screen you can exactly replicate one cycle, one complete cycle of this waveform. So on your screen, basically you will get to see something like this. Okay, you will get something like this. Tell me, is this clear or not? Is this clear? Okay, so you can see basically as time period of signal is equal to time period of sweep, so number of cycles displayed on the screen is equal to same. Now you can see what? Basically on this screen, let me assume, so once again this is Vy, this is Vx. Let me assume time period of the signal is t. Okay, this is time period of the signal and this is time period of the sweep. Okay, now here basically what I am going to tell you, that time period of sweep is equal to what? 2 times the signal, time period of signal. So now how many cycles are you going to see on the screen? See, I will explain. Basically, whatever is the time period of the sweep, same amount of time is going to be mapped on your horizontal axis of the screen. Okay, so basically you are going to map this point over here and this point over here. So how many cycles do you think are going to be visible on the screen? Very good. Why? Because you can see the sweep is going to, means the sweep signal, it is mapping basically this much time period, and in this much time period I can do what? I can take 2 times the signal, or basically 2 cycles of the signal. So basically your screen will look something like this. It's exactly not proper. Okay, so 2 times you will see. So now I'm going to generalize this. Basically, number of cycles displayed on screen denoted by Greek letter eta is equal to time period of sweep divided by time period of signal, or you can write it as frequency of signal divided by frequency of sweep. Okay, so you can see basically over here eta is how much? In this case eta is equal to 2. In this case eta is equal to 1, because time period of sweep is equal to time period of signal. So this is basically the case. Okay, clear up to this point? Clear? Okay, fine. So we have few kind of errors also. Okay, errors also, which I haven't discussed over here, but now we are going to see. See, basically this red color signal is your sweep signal, and this blue color signal is your unknown signal. Now you can see basically in this cases I have assumed that the amplitude of the sweep signal, if this is A1 and if this be A2 and this be minus A2, so I have assumed in each case that magnitude of A1 is always greater than or equal to magnitude of A2. I have always assumed this thing. I have always assumed this. What happens if this is not the case? So here you can see basically this is A1 and over here you have A2. So here you can see magnitude of A2 is greater than magnitude of A1. Can you see this or not? Can you see this? Tell me yes or no. Can you see this? Okay. So now how is your signal going to be seen on the screen? Okay. How will your screen look? Okay. So now one more thing you can see over here, that this is the time period of the signal and this is the time period of the sweep. One more thing to observe over here is that time period of sweep, it is less than the time period of the signal. This also, can you see this? These 2 points are visible in the diagram. See, up till this case I have assumed this, and over here basically the time period of signal, it is actually the multiple of time period of sweep. Okay, so that is why we can exactly replicate the signal, or I can basically replicate the exact cycles of the signal. Okay, but here you can see basically the time period of sweep is also less than the signal, and the amplitude, the maximum amplitude of the signal is greater than the maximum amplitude of your what? Your sweep signal. So now how will your signal basically look on the screen? See, basically this much part, or else uh, see, basically it will be difficult for you to understand simultaneously both the thing. So remove this part. You can write over here, means the diagram, let me change it a little bit. Okay, so you can see over here that it's okay. Time period of sweep is equal to time period of signal, because I have one more diagram where I can show this error, so it's okay. So here you can just see there is one problem, that the amplitude of your signal, magnitude of the amplitude of the signal, it is greater than the magnitude of amplitude of sweep. So now how much is it maximum? So you can see this much part, it will be removed, and even in the negative part, if you just take the image of this signal, so this much part is going to be not there. So now what you are going to do, basically the part that you cannot see, that will not be displayed on the screen. So on your screen, the signal will be displayed something like this. So this much part, it will be eliminated, and you can see remaining part will be there on the screen. Tell me, is this clear or not? So this is one of the error that you can see on the screen.
Sir, over here I have one doubt.
Yeah.
Sir, in this case, like the time period of sweep, we can 1 minute, sir.
Pardon, I couldn't hear you, Nitish. The last part,
Yeah,
what you said?
yeah, the voice was echoing. So, sir, in this case, the sweep time period of sweep, as we can like manipulate it by the RC circuit, right?
Yes, yes,
So,
yes, yes. You can
so
manipulate.
how can we like manipulate the amplitude of this sweep signal for the ramp signal?
Amplitude of the sweep, there is also a setting. Uh, Let me see. This one, this one. You can take the signal up or down. Okay, you can take the signal up or down. So that will basically, actually, you are moving the signal either up or down, but internally you are doing what? You are changing the amplitude of the sweep signal on your YT mode. Okay, are you getting
So
it?
yes, sir. Yes, sir. So, by doing this, like we can eliminate the error, right?
Yes, obviously you can eliminate the error. You can eliminate the error. I
Okay,
am
sir.
telling just with a proper improper setting how your signal will look on the screen. Okay. Now, can you draw this waveform that is going to be displayed on the screen? Can you draw this? Now, you will be very much tend to say that, sir, this much part is going to be eliminated. No, this is not going to be eliminated. Why? because you can see what, sorry, this is basically what, this is your, last time I have taken this as A1 and let this be A2. So you can see that A1, magnitude of A1 is greater than magnitude of A2. That means your amplitude of the signal is not going to be clipped anywhere. We always take the highest value, amplitude of the highest value of both the signals. So amplitude will not be clipped of the unknown signal, but you can see this is the time period of the sweep and this is the time period of the signal. So you can see time period of signal is greater than time period of sweep, and basically whatever is the time period of the sweep, that much time you map on the screen. So that is why this much part is going to be eliminated from the screen. So your screen will look something like this. So this time this point won't come in the middle, because if this was coming in the middle, then this whole signal would have been sketched. So this is a very good point. Remember this. You haven't set this point properly. So what is going to happen? Your screen, it will not look like this. See. So remember. So this is very wrong. No, this will be wrong. This will be wrong because your screen is symmetrical. Screen is symmetrical. So if this much part you are accommodating in this half of the screen, obviously the other half is going to accommodate this much part. So this is wrong. This is wrong. This signal I have drawn, this is wrong. Even I know the concept, but this is not the signal. This signal will look something like this. It will look something like this. Tell me, is it clear or not? So this concept you should know. This has not been asked in the examination, but still you should know this. Okay? Is it clear? Any doubt? Any doubt? Shishir? Okay, fine. So now let me ask you one thing. Okay? If suppose I tell you that both the condition, amplitude of sweep is greater than, magnitude of amplitude of sweep is greater than amplitude of the signal, and over here in both the cases I have given one condition, time period of signal is equal to half time period of sweep. So if this is the case, we know number of cycles displayed will be equal to what? Time period of signal divided by time period of sweep. Okay, time period of sweep divided by time period of signal. Okay, so this will be equal to 2. So number of signals displayed will be 2. So which option do you think is correct? Option A or option B? Tell me. Which
Sir,
option do you think?
over here, A1 is of the sweep signal, right? The amplitude of
This is
signal.
of the sweep, maximum amplitude of the sweep, and this is the maximum amplitude of the signal. So the whole waveform, there is no amplitude clipping. Okay, you can see. So now tell me which signal is going to be there on the screen. Tell
Like,
me.
as both the cycles can be displayed on the screen. So
Obviously, both the possibilities can be there. Okay, there can be two possibilities, and you can see that the display on the screen is not unique. Okay, it is not unique. Why? I am going to tell you. See, this sinusoidal signal, if it is ideal sinusoidal signal, it will go till infinity. Now, I don't know basically the CRO, whether the CRO, let me draw it over here. Okay, fine. So now I don't know basically the CRO screen, which cycle is it capturing? Whether it is capturing like this, okay, whether it is capturing like this, which is your option A, or is it capturing like this? Okay. So which option, sorry, have I done something wrong? Yeah, it should be over completed over here. Okay, so I don't know the CRO screen from where it is capturing, either from here to here or from here to here. Which one is it capturing? I don't know. Okay, tell me, is it clear or not what I am trying to say? I don't know which part of the signal, whether it is capturing when the signal is going in the positive side, first the positive half cycle is coming, or the first negative half cycle is coming. I don't know. Okay. So for that, there are two things which is going to uniquely define your waveform. So those two things are what? Basically, so first is your slope setting, another is your level setting. Okay, slope setting and level setting. So slope setting or level setting, there are basically two ways. Okay, two ways. Now in this case you can see basically I am capturing the positive slope first. So this is positive slope. At this point you will have zero slope because this is your maxima point. Then you have your negative slope. So if I want to define this signal, so you can see what? That over here in this, I have positive slope. So somewhere over here in this display also, you might see there is slope setting. Can you see somewhere? So okay, so where is it? Even I have to check. Level is over here, means slope and level. This is level, but I cannot see the slope. Where is it? Slope setting. I cannot see even. Can you see someplace where is the slope? I'm unable to see. Somewhere there is some combination which I don't know. Wait, let me check some other screen of CRO. So I am unable to see where is the slope setting. Okay. Where is this image? I don't know what is happening. So it's okay. In your question, there are these things given, positive slopes and negative slope. I'm unable to see this. I don't know why the images are not opening today. This is also not opening. So there is a slope setting present, okay? There is a switch basically, positive slope and negative slope. But I am not able to see this over here. Or there is actually a combination of switches with the help of with the help of which you will get the slope settings, okay? Means if you press two switches simultaneously, then it gives you the option for slope setting. I am not unable to open any one of the images. Not opening, I don't know why. So it's okay, fine. So over here I cannot see where is the slope setting. So it's okay. There is one slope setting, okay, remember, which basically differentiates. So if it is a positive slope, you can see you will get this signal. If it is set negative slope, so you will be getting this signal. Tell me, is this clear or not? Concept of slope. Is it clear? Is it clear? Tell me. Now next is what? Next is your level setting. Now what is this level setting? So level setting is basically, see over here in this 2 signal, I have taken the level to be as 0. Means the average value of the signal to be as 0. Now if suppose in this signal only, in this only, now I want you to draw one more diagram. Please understand this because there are 2-3 questions from this concept only. See, if I told you that here positive slope and level, let us assume it is positive, or I am telling it is +1. Okay, +1. Let me assume that this signal is 2 sine omega t. Okay, 2 sine omega t. So average value is what? Average value is 0. Now what happens basically, the moment I tell you that the level is +1, so their average value is actually equal to 1. Average value of the signal is equal to 1. So what will happen? This signal is going to shift somewhat upward like this. Basically, there are two lobes present or two cycles displayed over here, but the whole signal you can see the positive half is more than the negative half. Okay, so you will get what? You will get average value greater than 0. Tell me, have you understood this or not? Have you understood this? Please tell me. Now, if suppose I tell you with positive slope only, if my level setting, it is equal to -1 or less than 0, then what will happen? The same signal, it will be displayed twice on the screen, but it will look something like this. This whole signal will move downwards. Now this time you can see basically the negative half cycle is more than the positive half cycle, okay, which will cause a negative average value. of the signal. So these are the two settings with the help of which we classify the number of, means we can classify or distinguish the signals that are going to be displayed on the screen. One of them is what? One of them is your level setting, another is your slope setting. Okay, is it clear? Is it clear? So let me ask you one example. So I am telling you eta is equal to 1, positive slope, along with that level is negative. So how are you going to draw it? The signal. See, whenever you have such thing, so first here it is given that n is equal to 1. That means only one of the cycle will be displayed. So first draw that. Fine. This is one cycle. Positive slope. So you can differentiate. This is the positive slope. You can see over here that the level is negative. So that means what? This signal is for 0 level. Now if you want negative level, it will look something like this. Okay, it will look something like this. Tell me, is it clear or not? Is it clear? So this is how your signal will be displayed on the screen. Now this time this point is not going to intersect directly at this point. Okay, see, these two axes remain same. Now either you can take the signal up down, or you can take the signal, means you can transfer the signal in right or left directions also. Okay, so this will be the signal that will be displayed on the screen. Tell me, is it clear? So such kind of question might be asked in your multiple select type question. Okay, any issues, anyone? Or else we will study the next topic, that is what? That is your probes, means attenuation factor of CRO. So noted? Everybody noted this point? Chalo. So next topic is what? We have attenuation factor of CRO. So now here I cannot explain you the complete thing. You have to just understand and memorize the formula. Why I am going to tell you? Because this is little bit what means. I have just done what over here. Basically this is your CRO. Okay, CRO. So this CRO, this complete CRO, I have modeled it using your RC circuit, and there is this probe and cable which has some internal resistance and internal capacitance known as probe resistance and probe capacitance. So how are they basically modeled with the CRO, that we are going to see, and basically how does this probe cause attenuation in a signal, that thing we are going to see. Now why I told that it is difficult to explain, because you know what, that I cannot exactly model, because it's not in our course, exactly I cannot model this CRO. So that is why you have to understand that basically I have here what? I have one capacitance Ri. Now what is this Ri? Ri is the input resistance of CRO. So what do you think? Input resistance of CRO, should it be high or should it be low?
It
Should
should
it
be
be?
high.
Yes, very good. It should be high. Why it should be high? Then only I can eliminate the effect of what? I can eliminate the effect of what? Which effect?
Loading effect.
Very good. I can eliminate loading effect. So Shishir, are you also saying the same thing? So then only I will be able to eliminate loading effect. So input resistance of CRO should be very, very high. Now, what is this CI? Ci is the input capacitance of CRO. Okay, input capacitance of your CRO. Now, what is the CC? CC is basically the capacitance of the cable. Okay, cable. Now you might say, sir, where is the resistance of the cable? Resistance of the cable is very, very negligible. So that is why I haven't taken it over here. Okay, I haven't taken it over here. Resistance of the cable is very, very less, and obviously it comes in series. Okay, why not in parallel? Why not in parallel? Tell me. If suppose there was a resistance of cable in parallel, what would have happened?
There would be leakage of signal.
No. What will happen?
So,
Basically, this Ri is very, very high, and
so
Rc is,
overall combination will be very low.
yes, overall combination will be very low. Rc is approximately equal to 0. So that means the overall resistance will be very low. So input resistance of your CRO, it will be very less. So that is why it is not over here. Okay. Okay, fine. Next, Rp, it is the resistance of probe. Okay, and what is Cp? Cp is the capacitance of probe. Okay, capacitance of probe. Now you can see one thing, I can assume that Cc plus Ci, it is approximately equal to Ci. Okay, approximately equal to Ci, I can take it. Okay, because this capacitance is also not that much, so I can even write it as Ci dash also, whatever you want to say. So one more diagram I will make, or else it's okay. What I can do, I can make this as C1, and over here I can write Cc plus C1 is equal to Ci. Okay, so one more diagram let me make. So okay, fine, in the next page only I am going to draw. So let me remove this Cc. So now you can see this is basically what we have. Okay, this is what we basically have. Any doubt up to this point? Any doubt? Any doubt? Fine. Now I am going to take 2-3 cases over here. So I want you to make diagrams properly. Case 1. What is case 1? If we are measuring a low frequency signal. Low frequency signal. When we are measuring low frequency signal, omega equal to 0. If omega equal to 0, that means Xc will be capacitive reactance, it will be infinite. So wherever we have capacitance, please remove it. Okay. Okay, one thing I forgot to tell, that this is basically where we are going to take the output voltage V0. Okay. Fine. Any doubt up to this? Any doubt? Why this is infinite? Because we know capacitive reactance is equal to 1 by omega c. So capacitor will be open. So now attenuation factor, attenuation V0 by, attenuation factor is given by V0 by Vi, that will be equal to what? So this Rp and Ri, it is in series, so it will be equal to Ri divided by Rp plus Ri. Okay, Rp plus Ri. So this is the attenuation factor. Tell me, is it clear or not? Is it clear? Fine. Next case, what we have? Case 2. When we are measuring high frequency signal. Okay, high frequency signal, or you can even say omega equal to infinite. Okay, so now what will be happening basically? Okay, so I have, fine. So make one more diagram. Please don't do it in the same diagram. So now you can see one thing, that the moment I do this, what is going to happen? That Xc will be equal to 0. Why? Because capacitive reactance, it will be 0, as your capacitors are going to short. So now you can see basically this capacitor, which has very low impedance, it is in parallel with resistance which are high. Okay, which are high. So we know what parallel combination of high and low is actually equal to even lesser than this low value. Okay, so what I can do, I can ignore this resistance. Tell me yes or no. Can I ignore this resistance or not? Okay, so I can ignore this resistance. So remove this resistance part. So now V naught by Vi. See, once again what I am doing, V naught by Vi, this is your attenuation factor, and this will be equal to Ci by Cp plus Ci. Tell me, is this clear or not? Is it clear? Very quickly tell me yes or no. Is it okay or not? What? Are we waiting for something?
No, sir, this Ci and Cp are in series, right? So it will have.
Pardon? I couldn't hear you.
Sir, Ci and Cp are in series, right?
Yes.
So the equivalent like capacitance should be not addition. That I could not get.
I have applied. Okay. So tell me one thing. Basically, I have applied voltage divider rule. Is it correct? See, you have identified that there is something wrong. Okay. You have identified there is something wrong, but why is it wrong? You are not able to tell me that.
Sir, because the capacitance are in series, so the series capacitance not add.
Yaar, Nitish, I cannot hear you properly. Just tell me what is V1. What is V1? That's it. I want to know what is V1.
Sir, am I audible to you?
Yes, you are audible.
Sir, V1, sir, in this case, because the capacitance are in series, so they won't add like equivalently. They
I
will be
am
like,
just asking what is V1. Don't tell me they are going to add, they are going to subtract. I don't know. I am just asking what is V1. Just tell me that.
sir, it will be V into C2 upon C1 plus C2.
V into
C2
V C2
upon
divided by
C2.
C1 plus C2. What I have written over here? I want V naught. V naught is the what? V naught is basically the capacitance of this capacitor. So is it written correctly? And what you are telling me, Nitish, that this is not parallel series? What you are telling me? Chalo.
No,
I had given this formula, if you remember. Means if this was Z1, this was Z2. So I told V1 will be equal to V into Z1 divided by Z1 plus Z2. Are we remembering this? So if I put this formula V into Z1, Z1 is what? 1 by J omega C1 divided by 1 by J omega C1 plus 1 by J omega C2. Now if you take J omega common, this will come out to be V into 1 by C1 divided by 1 by C1 plus 1 by C2. Multiply numerator denominator by C1 C2. So this will be V C2 divided by C2 plus C1. So what you are telling me, sir, this is parallel series? What? Haven't I
no, sir.
derived this in the class?
Yeah. I actually got confused between that CI and CP over there.
That's confused. Shishir, what about you? Have we studied this in our network class or not?
Yes, sir.
So then why you couldn't tell me, sir, you have applied wrong? I have stressed when I took network, I have stressed that most of the time in capacitor, this mistakes happen. So V naught by Vi at this moment, it will be Cp by Ci plus Cp. So this is also what? This is attenuation factor in low frequency, and this is attenuation factor at high frequency. Okay, attenuation factor at high frequency. Now tell me one thing, do you have a circuit which gives you different attenuation factor at different frequency? Do you have a circuit which gives different attenuation at different frequency? This is not a filter. Okay, this circuit is not a filter. You could have said, yes sir, we have one circuit where we have different attenuation at different frequency. For example, a low pass filter. Okay, this is the magnitude and this is your frequency. So this is your cutoff frequency. This is, if this is A, this is A by root 2 magnitude of the signal. So you can say, sir, different magnitudes of a signal or different attenuation we have at different frequency. But this is not a filter signal. This is not a filter circuit. So obviously the attenuation factors are not going to be different. Attenuation factor at high frequency and at low frequency, both of them are going to be same. So you have to write that attenuation factor remains constant irrespective of frequency. So if that is the case, then equate both of this equation. Ri divided by Rp plus Ri is equal to Cp divided by Ci plus Cp. Okay, so both the attenuation factors are same. So now please cross multiply and see what you get. Rici plus Ricp is equal to Rpcp plus Ricp. So these two terms get cancelled. So we have Rici is equal to Rpcp. Okay, Rpcp. So this is the condition basically. This is the condition. Okay, this is the condition which we should maintain. See, I have what I am telling, please listen. So this is the condition which we should maintain so that attenuation factor remains constant irrespective of the frequency. Are you getting the point? Are you getting the point what I am telling? Okay, so this statement is kind of like So I will give you a simple example. So I told you, please don't smoke. Okay. Then I am giving you one more statement that 80% of the cancer can be avoided if you don't smoke. In the first statement, I told you don't smoke. In the in the first statement, I am going to tell you, please don't smoke because it causes cancer. In the second statement, I am going to tell you, cancer 80% of the time is caused due to smoking. Okay. So this is like that. I told that attenuation factor remains constant irrespective of the frequency. And here I am telling you, for your attenuation factor to remain constant, I should actually make your circuit constrained like this. Are you getting the point? Is it clear? Is it clear? Now tell me one thing. Attenuation factor, is it greater than 1 or is it less than 1? Option A, option B. Greater than 1 or less than 1?
It is less than 1.
Yes, very good. Attenuation factor should be less than 1 or it should be less than 1. So now let me assume that if your attenuation factor is equal to 1 by n. Okay, if it is equal to 1 by n. Okay, so what I can write? Ri by Rp plus Ri is equal to 1 by n. Okay, or over here what I can do, I can write your probe resistance as Rp plus Ri is equal to n Ri, or Rp is equal to n minus 1 into Ri. So this is one formula which you are going to see. Okay. Next, if you put it over here in this expression, so Cp Ci plus Cp is equal to 1 by n. So if you calculate Cp, so this will be Ci plus Cp is equal to Ncp. So Cp is equal to Ci divided by n minus 1. So these two formulas are very, very important. Most of the questions you can solve it using these two expressions. Even this one. Please tell me, is it clear? Is it clear? Any doubt in this? Any doubt? Fine. So questions, you might be thinking, sir, we are not solving any question. We are just studying theory. So questions also we will solve in the next class. Okay. So today let us finish the theory part. Okay. So next topic we have is what? It is known as your XY mode. See, up till now, whatever we have studied, all those things we have seen in your YT mode of CRO. In YT mode, basically your vertical plates, they get your unknown signal, and your horizontal plate, they get sweep signal. Okay. Or ramp signal. But in XY mode, what happens? We don't give ramp signal. Okay. So this is Vx, this is known signal. So in your XY mode of operation, what happens? I give in your, this was correct. I was seeing over here something else. Okay. So in XY mode, basically, instead of a ramp signal, which is given to your horizontal plate, I give a known signal, which is now not a ramp signal. Now, why am I doing this? Why am I doing this? Because I want to determine the phase of the unknown signal. Phase. I want to see what is the phase or what is the even your frequency of the unknown signal with respect to a known signal. See, basically the frequency that I was calculating over here, it was by calculating the divisions, okay, divisions in your x-axis. But here actually we don't need to calculate the divisions in your x-axis. Directly, if I know the frequency of known signal, I can calculate it. I can calculate the frequency of unknown signal, even the phase of the unknown signal, how we basically do with the help of your XY mode. Okay, XY mode. Now in XY mode, basically, okay, so let me see. In XY mode, basically what we do, we take help of your simple harmonic motion. Okay, simple harmonic motion. Now what is the simple harmonic motion? This is your simple harmonic motion where zeta is equal to 0. Now what is this zeta? What is zeta? Damping ratio, very good. So damping ratio. So here basically in XY mode, we take this known signal which has zeta equal to 0, or basically we have over here is simple harmonic motion. Okay. So one thing I want to tell, that in XY mode, basically I cannot measure the phase and frequency of a complex harmonic, or a damping simple harmonic motion. Okay, a damped harmonic motion I cannot take. That means when zeta is less than 1 or under damped signal, I cannot measure the phase or frequency. Only phase and frequency of signals which have zeta equal to 0, I can measure those. Tell me, is it clear or not? Is it clear? So how do we measure it basically? So we measure with the help of something known as Lissajous pattern. Okay, Lissajous pattern, or you might even see Lissajous curve. Now what is the difference between these two? We are going to see. But at the moment we have to see what is Lissajous pattern, Lissajous curve, all those things we have to study. Okay. So let us write few points first. Fine. We will, let me see if I have written it someplace. No. So write first point. Write first point. Lissajous pattern is a Cartesian plot. Lissajous pattern is a Cartesian plot, okay, of parametric equation exhibiting simple harmonic motion. Simple harmonic motion means what? Zeta equal to 0. So when we were in 11th class, we knew SHM means what? Simple harmonic motion means what? A motion that has repeated cycles and a constant frequency. Okay, so that is known as simple harmonic motion. So now what is this basically parametric equation? Parametric equation. Parametric equation.
It is in the form of t time.
What P?
The variables are in the form of t time.
Yeah, very good. in the form of time. So very good. I was listening actually P, not T. Okay. So let us assume yt is equal to something like this, sine omega t plus phi. Okay, something let us take, or you can even take it as omega 1. Okay, next x of t is equal to b sine omega 2t. So basically, I am plotting this Cartesian coordinate in terms of time only. Okay, I am taking it in terms of time. So now, one thing I want to tell, Lissajous pattern. Okay, let me tell you here itself. Lissajous, what is Lissajous pattern and Lissajous curve? So Lissajous pattern, this is always a closed curve. Closed curve means you can draw this curve with a single stroke of your pen. Single stroke of your pen means something like this, 8. Okay, means there is no repetition. So we are going to see something like this. Closed curve means what? That with a single stroke of pen, you can draw it without any repetition. Whereas Lissajous curve, they are open curve. Means you will find some open end. Okay, you will find some open end. In Lissajous pattern, you won't find open end. It will be always a closed curve. Okay, sometimes even these two are combinedly called as Bowditch curve also. Bowditch curve or Bowditch pattern also. Okay. Okay. So this is what? This is your parametric equation. So sometimes we even used to write it like this: x is equal to r cos t in your EMT, if you remember, y is equal to r sin t, and then we used means something like this. This is r, this is theta. So this x is equal to r cos means theta. So here basically this is t, and this one you can write it as y sin, sorry, r sine theta. Now time, time, is it a radian or a degree quantity?
Radians.
Yes, radian quantity. Okay, time is a radian quantity. So I can denote it over here. So r will be equal to under root of x square plus y square, and theta is equal to tan inverse of y by x. So this is also a parametric equation. Okay, parametric equation, you can draw it. So basically in our xy plot, usually we have both the signals as sinusoidal. See, in our syllabus we have to deal with sinusoidal, cosinusoidal signal or sinusoidal signals. Okay, so that is why I have taken both the curves like this. Now this Lissajous pattern, okay, Lissajous pattern, it is highly sensitive to A by B ratio. This ratio of A by B. Okay, it is highly sensitive to the ratio of A by B. Okay, so one thing I want to say, if this ratio of, okay, sorry, I am telling A by B over here and I have taken something else over here. So do you want all the notations in terms of textbook, or if I change the notation, it will be okay with you? Tell me yes or no. You want notations of the textbook, or if I change, it will be okay? Okay, let me use textbook notations only. So in textbook, in all the standard textbook, so as I was doing it from my own mind only, so that is why I took omega 1 and omega 2, and then I was telling A by B. Okay, so in textbook you will find they have replaced this omega 1 by A and omega 2 by B. So basically this Lissajous pattern, it is highly sensitive to this A by B ratio, or basically the ratio of frequency of the two signals. Okay, ratio of frequencies of the two signals. So this ratio actually gives us information about the frequency of unknown signal. Now please don't ask me how, sir. Okay, because we are going to see at the moment how we are getting to know. Now one thing you should know, if A by B ratio is a rational number, or omega 1 by omega 2, I had taken omega 1, omega 2. If it is a rational number, I will get a closed curve. If A by B is equal to irrational number, I get what? I get open curve. Open curve means what? Lissajous curve, and this is Lissajous pattern. Okay? Tell me, up to this point, is it clear? Is it clear? Now first let us see how to draw this Lissajous pattern. Okay, how we draw basically this Lissajous pattern. So we have these two signals, y of t is equal to 2 sine omega t and x of t is equal to 2 sine omega t. Can we draw these two signals on the screen of CRO? Okay, so if I draw it like this, it will take a lot of time actually, so it's okay. Let us not make it complex, keep it simple. So this is the signal that is given to your vertical plate. This is the signal given to your horizontal plate. Now let us see what is the pattern that we observe on your CRO screen. Now it will be very simple, okay? So I thought I will make it like that, but it's actually complex to understand, so it's okay. Let us keep it as simple as possible, okay? So let me take few time instants. Fine, this is also okay. See, this is the last topic and this is the most important topic. Now see, basically what is happening, see at T naught, previously this Vx was what? This Vx was a ramp signal or a sweep signal. This time it is not a ramp signal, both of them are sinusoidal signals, okay? So here here I have taken that both the signals have same frequency and zero phase difference. I have taken just for explanation sake. Okay. So here you can see what? Basically, that at time t equal to 0. Okay. At time t equal to 0, what is the value of both the signals? It is your 0 and 0. 0, 0. Now at t1, now corresponding to 0, 0, where are the electrons going to hit in the screen? It is going to hit someplace over here. Now at T1 means there are million numbers of electrons which are going to hit in between these 2 points also, because there are, this is basically an analog voltages. So that is why there will be deflections corresponding to the electrons also. But I have taken another electron which is being emitted over here. So for this particular value, you have 2 volt, 2 volt. So this is 2 and this is 2. So corresponding to this 2, your electrons, it might hit over here. Okay, 2. Now next is T2. So both of them have 0 voltages. So once again, it is going to come over here. Then you have T3, which is minus 2, minus 2. This is minus 2 means somewhere over here it is going to hit. And then once again T4 we have, where again 0, 0. So it will come to this point. So how is your curve basically? So basically, it is like this and then like this. So basically this signal, it will continuously look like this. So we will have one, because the frequency is very, very high. So we will see a constant line. Okay, constant line. Can you tell me what will be this angle? Theta. What will be this angle?
Will it be 45 degrees?
Obviously it is going to be 45 degree. Why? Because let me assume if this is corresponding to 2, 2, this is corresponding to minus 2, 2. So you can see whatever is the x-axis intercept, y-axis intercept, it is the same. So this theta is equal to 45 degree. So for a signal, you can see this signal was unknown, this was known. So if I get a Lissajous curve, something like this, what you can say, that the frequency of the signal is same as the known signal and the phase difference is 0. Okay, phase difference is 0. Tell me, is it clear or not? Is it clear? Any doubt? So this is one of the Lissajous pattern. Now let us take one more example. Okay. I've taken yx. Okay, fine. So this is your Vx. Vy will look something like this. So this is T0, this is T1, this is T2, this is T3, this is T4. Okay, both the signals have same amplitude. So look at this T0. Okay, so once again let me draw the screen of CRO. Okay, so this is the screen of CRO. This is X, this is Y. So now look once again. So at T0, over here this is 2, this is minus 2. So T naught Vx is equal to 2, Vy is equal to 0. So Vy is equal to 0, Vy is equal to 0 and Vx is equal to 2. Where will this point be? It will be someplace over here. Means the electron corresponding to this 2 voltage, it will strike the screen over here. Next, T1, you can see what? That sorry, have I taken it the wrong? Yes, I have taken wrong value. So this was Vy. So this was 2, this was 0. So basically it will hit somewhere over here. Now next point at T1, Vy is equal to 0, Vx is equal to 2. So what is happening? So Vy is equal to 0 and Vx is equal to 2. So Vy 0, Vx 2 means some place over here. Okay. Next, at your T2, you can see Vy is minus 2 and Vx is 0. So minus 2, Vy is minus 2 means someplace over here and Vx 0. So obviously it is going to hit over here. Next, for T3, you can see what? For T3, it is basically your Vy is equal to 0, Vx is equal to minus 2. So this will be someplace over here. And in the last case, T4, you can see that it is in your plus 2, Vy is equal to plus 2 and this is equal to 0. See, one thing if you note, for Lissajous curve, the point from where we start, actually we terminate at the same point. Look, from where we are starting, we are terminating at the same point. So this is actually Lissajous pattern. In Lissajous curve, this won't happen because it will be an open-ended curve. So open-ended curve, it will have starting and terminating points at different locations. So over here you can see the point from where we started, the same point we are terminating. And if you make a locus of all these points, so basically my diagram is not that proper. Okay. So this will actually look like a circle. Means what? This Lissajous pattern, it will be a circle. So now when are we getting circle? When are we getting circle? Can you tell me? When are we getting circle? So circle we are getting when basically amplitude is the same. Okay, amplitude is same. Frequency is also the same, but phase difference is that of 90 degree. Phase difference is 90 degree. See, basically I am trying to explain that I am measuring phase over here. Okay, phase over here. Why? Because I can manipulate this amplitude. I can manipulate this amplitude. It's up to me. The thing that I am measuring over here is what? Basically I am measuring the phase. I am measuring the phase. Is it clear? Tell me yes or no. Is it clear?
Yes, sir.
Any doubt?
No, sir.
From your voice, I think it's means you are not that much satisfied with the explanation that I have given.
No, sir. It's understood.
Okay, fine. So now, basically, I have taken two things. So whenever we are going to see now measurement of phase and frequency. So first we are going to see the measurement of phase. Okay, measurement of phase. How do we measure phase? So for while measurement of phase, what we do, we keep the amplitude as constant. We keep the amplitude as constant. Okay, we keep amplitude as constant. Okay, do you want me to sketch one more diagram? Chalo, we will sketch one more diagram. So x of t, let us take it as 2 sine omega t. So while we measure phase, we keep the amplitude same, 2 sine omega t plus 45 degree. Now I want you to sketch this yourself. So at this time also, I am going to do one thing. I am not going to take time anymore. Sorry, T1, T0 I am not going to take. So I want you to sketch this yourself till the time I am also sketching. So this signal we are going to sketch now. Now exactly I am not able to draw it over here, okay? So this is little bit difficult. Whole signal has to be phase shifted. At this point it is 1 by root 2. Here it will be 1. Here once again 1 by root 2. Here it will be 0. Minus 1 by root 2. Minus 1. Minus 1 by root 2. Have I done some mistake? So this is 45, 90, 135. This is 180, 215. This is 270, 315, 360. Okay. I think it's okay. I will just keep it like this: 0, pi by 4, pi by 2. This is 3 pi by 4. So you guys are going to tell me the value. This is pi. This is your what? This is your 5 pi by 4. This is your 6 pi, means 3 pi by 2. Okay. This is your 6 pi by 2, 7 pi by 2. This is 8 pi by 2, means 2 pi. 4 pi by 2. I think 4 pi by 2. Yes. 4 pi by 2. Yes. So this is 7 pi by 4. I'm sorry. This is 3 pi by 2. Yes, correct. Yeah. So now if you take different time instants over here, time. So this is x, this is y. So this is 0, pi by 4, pi by 2, or let us let us not take so many time instants. So pi by 2, then let us say for pi, 3 pi by 2 and 2 pi. Okay. So what this will be? This will be equal to 0. Over here, if we take this, so this will be 1 by root 2. If I take pi by 2, this will be 2. Means over here, let me also assume this as 1, 1 only. 1, 1. So this will be 1. This will be pi by 2 means 90, 135. So this will be minus 1 by root 2. For pi, this will be 0. This will be so this point will be what? 180 plus 45. So that is 215. This will be 1 by root 2, I think. This point will be once again 3 pi by 2. So this, sorry, I am messing up something over here. Please tell me all the values. I am just messing up the values. Okay. Use your calculator and let me know. So this is simple. This is pi by 2 means 1. This will be 0. This will be minus 1. And this is 0. So over here, if I have 90 plus 45, 135. So that is minus 1 by root. Sorry, even this value
Sir,
is
it will
correct.
be plus 1 by root.
What? 135, na? Yeah, it will be minus 1, I think. No, plus 1.
Oh, sir,
Plus 1.
1
Plus 1.
by root 2, no, sir?
Yeah,
So,
this will be
Plus
plus
1 by root 2.
plus 1 by root 2. Correct. This is 180 plus 45. So that is 215. That is minus 1 by root 2. Okay. This is 3 pi by 2. Means 90, 315. So this is also what? This is also minus 1 by root 2. Yeah, correct. Minus 1 by root 2. And this will be 2 pi. So this is 1 by root 2. Tell me if I am not wrong anywhere. Is it correct? Any doubt?
yes, sir, it is.
Okay. So now let us sketch this. So this point 0, 1 by root 2. So y 1 by root 2 means someplace over here. Next is what? X is 1 and this is still 1 by root 2. Okay. So x is 1, 1 by root 2. Same point? No, this shouldn't be the case. Somewhere we have made some mistake or what? Zero minus 1 by root 2. No, it's correct actually. Let me see. 0 minus 1 by root 2. Okay. Minus 1 minus 1 by root 2. 0 1 by root 2. Okay, so this will look something like this. It will be basically a form of ellipse. Okay, yes, sorry. So this will form an ellipse, something like this. My structure is not good, but this will basically form an ellipse where your Lisa-just pattern. So let me just make it one more time. So we have basically taken this point, this point, this point, this point and this point. Okay, if we had taken few more points, we would have got this figure something like this. Okay, so this is your Lisa just pattern. Okay, Lisa just pattern. So from this basically we can measure the phase. How we can measure the phase? Now we are going to see that. Okay, so measurement of phase and frequency. In this, the first part is what? Measurement of phase. Tell me, is it clear? Is everything clear up to this point? Is it clear?
Yes, sir.
Okay, so now let us see how do we measure phase. Okay, how do we measure phase? So we have seen from these means do 2-3 example that when we have two equal amplitude and we have frequency means frequency what? Frequency is also same. If we want to calculate the phase difference, so what we can see, we have a ellipsoidal patterns. Okay, ellipse pattern, or if phase is zero, we have a straight line. So circle is a special case of an ellipse. Can anyone tell me the condition? Circle is a what? It is a special case of ellipse where the major axis and the minor axis are same. So now in an ellipse there are two axes. One is major axis, another is minor axis. Now here in my diagram, the ellipse is not that perfect. This is what? This red color line. What is this red color line? So we have forgotten. What? So when I said major axis, minor axis, at least you could have told me, sir, I don't know. We don't know what is major, minor axis. So this is the major axis, this is the minor axis of ellipse. So in circle, you can see if this I consider as major axis and this as minor axis, no, basically both the magnitude of major axis and minor axis, it is the same thing. So circle is a special case of an ellipse. Okay. So now you can see what we have, basically either we get circle or we get ellipse or we get straight line. Okay. So when we have two sinusoids which have equal voltage and frequency, but if we have a different phase shift, we obtain an ellipse or a straight line. Okay. Now how do we basically determine the phase then? Okay. How we determine the phase? Now let me draw one more diagram properly. Did you understand what is major axis, minor axis? At least tell me yes or no.
Yes, sir.
Now my ellipse is not that perfect, but you can understand. Now this is what? This is the major axis. This is the minor axis. Okay, major axis, minor axis. Or you might even get one ellipse that looks like this. Okay, you might get even like this. So now with the help of this, how do we basically measure your phase that we have to see? Now I am going to mark few positions over here. Let this be y1, and this much distance be y2. Okay, another is what? Another we can make is let this much is x1 and this much point is x2. Similarly over here also we can say this is what? This is y1, this much distance is y2, I'm very sorry, this diagram, it is not looking exactly the same. So let this much be x1 and this distance be x2. Please tell me, have you understood this or not? Have you understood this two thing? What I am trying to say? What are this x1, x2, y1, y2? Is it clear? Please tell me. Okay, fine. So now over here you can see basically that if I take the sine of y2 by y1, or if I take sine of x2 by x1, I am going to get the phase angle. I am always going to get the phase angle. See, if in this case, so actually I cannot determine, means this point I can determine. This is what? This is 1 by root 2. This point will be 1, 1. Okay, this will be 1, 1. This will be 1, 1. Okay, maximum will be 1, 1. So if you even see from here, sine phi is equal to, so over here, this point is 1 by root 2 divided by 1, because that is what I have taken, the ratio of this point to this point where this ellipse is intersecting the y-axis. So you can see phi comes out to be 45 degree. Next, come over here. So here you can see basically these 2 points are going to intersect. Okay, so here sine phi is equal to 1 by 1, so phi is equal to 90 degree. Please tell me, is this concept clear? So now don't ask me, sir, from where are we getting this? So basically these are the properties of Lissajous pattern with the help of which we can determine the phase. Is it clear? Is it clear? Tell me. Now, if in this case only, if I had taken y of t as sine omega t plus 135 degree, if I had taken it like this, or if I had taken sine omega t plus 315 degree, then I would have got this curve. Okay, this Lissajous pattern. If over here I would have taken sine omega t plus 215 degree, I would have got this curve. Same this curve only. So always remember, if your major axis of the ellipse, what I am telling, if the major axis of ellipse lies between first and third quadrant, okay, first and third quadrant, if it lies between first and third quadrant, then phase shift can be either, now there are two possibilities of phase shift. Either phase shift will be from 0 to 90 degree, or it will be what? It will be between 180 and 270 degree. If major axis of the ellipse lies between second and fourth quadrant, this is second and fourth quadrant, once again there are two possibilities. Either phase shift will be from 90 to 180 degree, or it will be what? It will be 270 degree to 360 degree. Is it clear? Tell me. Is it clear? So now these things are asked in the examination. It is asked in the examination. So I will just give you few points over here or few example how actually your Lisa-Just pattern looks. See, if it is 0 degree, so here in this case phase shift is 0, phase shift is 15 degree, phase shift is 30 degree, phase shift is 60 degree, phase shift is 90 degree. So if it is 0 degree, it will look like this. If it is 15 degree, it will look like this. If it is 30 degree, now this ellipse will be a little bit fatter. Okay, it will look like this. If it is 60 degree, it will be more fat. Okay, it will look something like this. And for 90 degree, it will be a perfect circle. Okay, so this is basically what the Lisa-Just pattern for finding out the phase. Tell me, is it clear? Any doubt? So next we have is what? Measurement of frequency. So for measurement of frequency, this will be the last topic. I think we can do it tomorrow. So tomorrow also I want to take one class. Okay, tomorrow morning. Are you guys available? Morning?
Yes, sir.
So when do you want me to take class? Nitish, Shishir?
At 10 a.m.
10 is fine, Shishir?
Yes, sir, it's fine with me.
Nitish, what about you?
Yes, sir. Fine.
10. So tomorrow 10 a.m. then we will finish this topic. We will see few questions and we will start the next topic also. Okay, is it clear? Any doubt?
Okay.
So are you guys practicing questions or not? Okay, so one thing I will do, I will send one book to Nitish. Nitish, please forward it to Shishir also. Okay, is it okay?
Yes, sir.
Fine. Okay, then see you tomorrow.